In this lesson I am discussing about the different parameters related with the solar energy. First one is the air mass. So air mass is denoted by Ma. Air mass represent how much atmosphere the solar radiation has to pass through before reaching the earth's surface. The air mass Ma equals to 1 when the sun is directly overhead at the sea level, that means the zenith. The value of Ma equals to 2 when the zenith angle theta z is 60 degree, and Ma equals to 1 by cos theta z, that is equals to sec theta z when Ma is greater than 3, and the value of Ma is 0 just above the earth atmosphere. So these are the value of the air mass Ma. Now the solar constant. What is solar constant? The rate at which solar radiation strikes Earth's upper atmosphere is expressed as the solar constant. This is the average amount of energy received in a unit of time on a unit of area perpendicular to the sun's direction at the mean direction of the Earth from the sun. While the distance between the Earth and sun varies as the Earth moves around the sun on the elliptical orbits, the variation of distance does not have significant effect on the amount of solar radiation reaches the Earth. The generally accepted solar constant is 1368 watt per meter square, and here there is a diagram where this is the position of the sun and this is the Earth, and this is the Earth diameter, that is 12,800 kilometer, and surrounding the Earth diameter there are the atmosphere, where the distance between the diameter of the Earth to the atmosphere end is 8,000 kilometers. So in this point, that is the solar constant. The solar constant ISC is the energy from the sun received on a unit area perpendicular to solar rays at the means of distance from the sun, that is 1.5 into 10 to the power 8 kilometer outside the atmosphere. The solar constant includes all types of solar radiations, not just the visible light like radio, infrared, visible light, ultraviolet, X-ray, etc. It is measured by the roughly 1367 kilowatt per meter square. Now, the solar constant characterized by the following. First point, it is constant and not affected by daily, seasonal, atmospheric conditions, clarity of the atmosphere, etc. Next point, it is on a unit area of imaginary spherical surface around Earth atmosphere from mean distance between the sun and the Earth. Next point, it is the surface normal to the sun's ray. Next, it has measured the value of 1353 watt per meter square. The value of solar constant remains constant throughout the year. However, this value changes with location because Earth-Sun distance changes with times. Now, the relation with extraterrestrial radiation and solar constant. Here, I0 is the apparent extraterrestrial solar radiation watt per meter square. ISC is the solar constant, that is equals to 1350 watt per meter square. N is the number of day of the year, counting January 1 as the first day of the year. So I0 equals to ISC into under bracket 1 plus 0.33 cos 360 in n minus 2 divided by 365. So I0 equivalent to ISC into under bracket 1 plus 0.33 cos 360 n divided by 365. The standard value of solar constant based on the experimental measurement is 1367 watt per meter square with accuracy of 1.5% plus minus. Now these are another diagram. This is the diameter of the sun, and this is the diameter of the earth. The diameter of the sun is 1.39 into 10 to the power 9 meter, whereas the diameter of the earth is 1.27 into 10 to the power 7 meters. So solar constant is 1353 watt per meter square, and the distance equals to 1.495 into 10 meter, 10 to the power 11 meters with plus minus 1.7% tolerance. The distance between sun and the earth varies by plus minus 1.7% due to the elliptical orbit of the earth around the sun. Now, earth-sun angle. So this is the position of the sun and this is the position of the earth. The position of the earth varies throughout the year. So this is in this situation, that is the 21st December, this is the 21st March, and this position indicates the 21st June, and this position is the 23rd September. Now, the concept of latitude and longitude, that is theta and alpha. Latitude and longitude are the coordinates of a point on Earth's surface. A location of the Earth's surface may be specified by latitude and longitude and equivalent, but the elevation does not directly enter into the calculations of the different angle through may affect solar radiation received. The latitude varies from minus 90 degree to plus 90 degree, and the longitude varies from 0 degree to 180 degree east or 0 degree to 180 degree west. Now, these are the position. That is here the phi equals to 90 degree, phi equals to minus 90 degree. That is lambda equals to 90 degree, lambda here the lambda equals to minus 90 degree, and the latitude is theta and longitude is alpha. Now, the latitude of a point on the Earth's surface in the angle between the equilateral plane and the line that passes through the point and normal to the surface. The north pole is 90 degree north and the south pole is 90 degrees south. The 0 degree parallel of the latitude and design the equators. The latitude lambda of a point on the Earth's surface. In the angle east or west from the different meridian to another meridian that passes through the points. Now the latitude and longitude, especially the position on any location on the planet, but do not count for altitude or depth. Now the hour angles. W. Hour angle convert the local solar time LST into the number of degree which the sun moves across the sky. Hour angle is 0 degree at solar noon, since the Earth rotates 15 degree. Earth rotates 15 degree per hour. Each hours away from solar noon corresponds to an angular movement of the sun in the sky of 15 degree. In the morning, the hour angle is negative, and in the afternoon, the hour angle is positive. At solar hour angle is at solar noon, the hour angle is 0 degree. With the time before solar noon, hour angle is negative degree, and the local time after solar noon expressed as positive degree. For example, at 10:30 a.m., the local apparent time, the hour angle is minus 22.5 degree, that is 15 degree per hour times 1.5 hours before the noon. That means hour angle is an The displacement of the sun east to west of the local meridian due to the rotation of the earth on its axis at the angle of 15 degree per hour. So our angle W equals to 15 degree into under bracket 12 minus LST, where LST is the local solar time. Now the term solar noon. Solar noon defined to be that time of the day at which the sun's rays are directed perpendicular to a given line of longitudinal positions. Thus, the solar noon occurs at the some instant for all local angles and common lines of the longitude. Solar noon will occur 1 hour earlier for every 15 degree of the longitude to the east of a given line and 1 hour later for every 15 degree west. This is because it takes the earth 24 hours to rotate 360 degree angle. Now the altitude angle alpha or solar altitude. So here this is the diagram where this is the position of the sun and this is an object, and this is an angle alpha, that is solar altitude angle. The altitude angle, sometimes referred to as the solar elevation angle, describe how high the sun appears in the sky. The angle is measured between the imaginary line between the observer and the sun and the horizontal plane the observer is standing on. The altitude angle is negative when the sun drops below the horizon. So in the diagram, replaced N with S for observer is the southern hemisphere. The altitude angle is calculated as follows: sin L equals to cos L into cos D into cos H plus under bracket sin L into sin D, where L is the solar altitude angle, L is the latitude, D is the declination, and H is the hour angle. Now these are the position. So this is north and this is south and this is the east and this is west. That is the total mapping system. So these are the horizontal plane and this angle is the azimuth, that is the angle between the horizontal and the S, and this is the altitude, this is the angle between the horizontal and the sun, and this is the vertical line, and the angular displacement between the altitude and the vertical angle is called zenith, that is theta z, and this is the ground plane, and this here is the observer. Now the zenith angle theta z. Solar zenith angle is the angle between the local zenith and the line of sight from the point of the to the sun. That means the higher the sun in the sky, to lower the solar zenith angle. On the other angle of the figure, the angle between the local zenith and the line of the sight to be is indicated is called the viewing zenith angle. So this is the viewing zenith angle and this is the solar zenith angle. The solar zenith angle is the angle between the sun and the zenith, and the between zenith the angle is called viewing zenith angle. Now the solar azimuth angle. So here this is the diagrams, these are the diagrams. So it is polar angle in degree along with the horizontal east to the west of the north, or in a horizontal angle measured from north to the horizontal projection of the sun's ray. The angle is positive when measured west side. Azimuth angle varies throughout the day according to the position changing of the sun. The sun rises directly east and set directly to the west regardless of the latitude, thus making azimuth angle 90 degree at sunrise and 270 degree at sunset condition.